back. We're going to go into the lab now and have a look at some crystal devices and a network analyzer. The network analyzer is a machine, a piece of electronics, that sends a AC of varying frequency to our sample. So it sends an AC frequency and then it steps up and sends another one, keeps going, sends it to the sample and measures back whether that's distorted, how it's distorted, what comes back. Can do it in 1-port or a 2-port measurement, so you can send it down the same wire, same pair of wires, or you can have sending wires and collecting wires depending on what you want to measure. It's a tool for measuring circuits, measuring antenna, measuring all kinds of things, but in this case we're going to use it to measure one component, which is the quartz crystal or resonator of some sort. I've got some different resonators that we're going to have a quick look at today, just so that you can get a little bit of familiarity with the technique. Hello, welcome back. This time we're having a look at this quartz crystal circuit, but in this case we've got a very simple one. It's a buzzer, so a piezoelectric buzzer, which works with the same principle, but it's not quite the same. It's a lot lower frequency. I've connected it to 2 wires to port 1, and I will see off camera whether I can get it to work. This is a network analyzer, so what it does is it sends AC to my crystal and it sweeps frequency. When it hits a resonance it will absorb, and so it will tend to be absorbed into the crystal, causing it to move faster and further. But if it's on resonance it will lose less energy, and we will see that on this trace. Right, I'm back and I've got it set up. So now we're scanning from 4 kilohertz, I think, 4 kilohertz up to 12 kilohertz, I think. And these peaks in here, so this is it scanning. These peaks in here are where it resonates, so that's where it's absorbing the most energy. I'm going to move you up to it so you can hear. Now I'm going to touch it, and then you can see the peaks change. So what you can see is the peaks are always there, but some of them are bigger and smaller depending on what I do. That's because it's a little bit free to oscillate and it's doing something to generate sound. I'm not actually sure which direction this is oscillating, but it's probably curling the metal below. So this is another crystal. You can see it's the driver part out of an ultrasonic bath. What you can see up here is a scale from 1 kilohertz up to 200 kilohertz, and if I apply this electrode you can see this peak grows in. I'm averaging over something, so that's why they grow in. You can see that there are 3 peaks because there are multiples of frequency that fit inside my crystal, so that I get one, sort of the main resonance band, and then 3 times it and 5 times it. So you get resonances at reasonably equal distances from each other in frequency. Now we can zoom in a little bit. Let's try and keep that on there. And as we can see, some of the features are disappearing because they are artifacts of measurement. Let's do auto scale. So we get a nice peak from this one. This one is a single frequency oscillator, the other one is a buzzer, so it's not surprising. This job is much more similar to the quartz crystal. It's going to oscillate at 1 frequency and not many. So we can have a quick look at what the other things do, if I can remember how to do that. Yes, okay, here. So we can look at the impedance, and get back on it, or auto scale that. Ooh, that's ugly. Here is the phase difference. Whoops. Yeah. So it doesn't like that because it takes a lot of power. So it has a large phase offset at the resonance, so it switches from behind to in front effectively. Because it's trying to go faster than it, when it's too slow, and it's trying to go slower than it when it's too fast, so it shifts the phase offset. And it can only to compensate to a certain amount, so only in this range can it force the circuit closer to what it wants to get to, but it can still delay it a certain amount or increase it a certain amount. So I'm wondering why that is so weird looking, but that one was better, with a nicer peak. If we go back, we can also change and see some other things, but these are all related to each other. There aren't actually that many different things in there. So that is one that it's a fairly standard peak where it's shifting in one direction, and on one side and one direction on the other side. Effectively they are it's the derivative of the last curve we saw. Okay, so that's what we would see. That's what we will also see on a quartz crystal, but the quartz crystal oscillates at a much higher frequency. This is only kilohertz, and the quartz crystal is at megahertz. We can't hear the quartz crystal oscillating, and we have to be a lot more careful about keeping it clean, which is why I prefer these ones. It also is a lot easier. Okay, signal disappears. It's a lot easier to look at these ones. This is a big sheet, and it's oscillating, and what it's for is putting onto a bath or putting onto something that we want to shake, and it will shake it really violently. We have to power it a lot more powerfully than this. This is only giving a small kick, so it's only moving a few nanometers. If we want it to do something, we'll have to hit it a bit harder with much more voltage.